two biggest skills that we're going to be working on throughout this semester are the decomposition and recomposition of problems. There's this sort of secret belief, or sometimes a not-so-secret belief, that the secret to becoming a good programmer is to memorize all of the things that you can do in a programming language. But I'm going to dispel that notion, if for no other reason than knowing that the Java 7 base library comes with well over 600 classes and tens of thousands of methods that are built in, which is to say that you could spend an entire lifetime studying this and still not learn everything, particularly when you consider all of the frameworks and libraries that are built by other people. In addition, what use are you if you can only do things in Java? Most of you will end up, if you do any programming at all, working with Excel spreadsheets or writing scripts in Python or perhaps Visual Basic in order to accomplish problems that you might see. A good number of you will not be professional Java developers, though the reason that we use this language is because it's good for teaching some of the fundamental constructs. Now, the things that we're going to look at, though, are decomposition and recomposition. Decomposition refers to breaking down a problem into simpler parts and then solving those parts. A lot of programming is really about pattern matching, which is to say that it's about figuring out when something looks sort of like something else that you already know how to do, and then seeing if that works. A piece of software, for example, the healthcare.gov website, or even an operating system or Microsoft Word, is going to have somewhere between 10,000 and 1 million lines of code, which is more than most people can keep straight in their brains. And rather than tackle everything at once, the way that we create projects of that scope and of that scale is to break them down into simpler parts. And as soon as we have them down into the simplest possible parts, we just solve all of those things. Of course, after we've solved all the individual parts, we have to put it all together into a thing that looks like a complete program. And this is called recomposition. Most of what we're going to be looking at over the course of this class is decomposition and some very basic recomposition, which is to say that we're not going to really get into sort of the broader architectural concerns of all of this, which is okay. You've got lots of time to get into that. Now, almost all the programs that we write in this class, which is to say all but one or two, are going to take some information from the user, usually from the command line, that is to say, usually we'll ask our user to type stuff in, we'll do some stuff to that information, and then we'll output the results to the screen. And really, almost every single piece of software ever written falls under this pattern in some fashion, which is to say your average word processor or Office application is going to take information from the user in terms of what they type in, do some stuff to it, and then print it to the screen and or save it to a file and or send it to a printer. A video game is going to take information from the user in terms of their input as well as information from, say, game levels that might have been designed by the designers. We'll take all of that and make the game work, and then we'll put the results on the screen, usually several times per second. And even, and this is a thing that you'll look at if you're into bioinformatics or any sort of research, you might write software that collects information from sensors or from other measurement devices, does some number crunching to that information, and then stores the results somewhere, perhaps as a graph or as a chart or even as a big honkin' table of data. Most of the programs that exist right now can be thought of as taking information from one or more sources, doing some stuff to it, and then putting the results in one or more places. So ultimately, what we can then say is that programming is mostly about information, rather than about all those magical incantations that Frederick Brooks talks about. We're mostly talking about information, how we represent it internally, using variables and data types. We'll talk more about that in a bit. And then what we do with it. As there are ways, using things like data structures, that we can make our lives easier, and there are also ways, using things like data structures, that we can make our lives more difficult. And when I talk about data structures, what I really mean is just the way that we represent information internally. And we'll talk very, very basically about it. But especially if you take CSCI 1620, which is the sequel to this course, you'll end up spending a lot of time with it. Now, Linus Torvalds, who's the designer and programmer of Linux, or the lead programmer of Linux, had this to say: "I will in fact claim that the difference between a bad programmer and a good one is whether he considers his code or his data structures more important. Bad programmers worry about code. Good programmers worry about data structures and their relationships. It's really all about the information." As far as what you do with the information, those are things that, if your information is represented correctly, that's a problem that almost solves itself. That's Linus Torvalds. And again, I apologize for all of the gendered pronouns in these quotations. Now, over the course of this class, we're going to talk a lot about how we take information, how we represent it internally, and how we do stuff to it. Next time we meet, which will be Tuesday, we're going to talk about the basic structure of a Java source code file. We'll talk about the compiling process, we'll talk about running, and we'll also talk about basic output and input. That is to say, putting stuff to the screen and then collecting information from the user. So your reading assignment then is to take the Deitel and Deitel Java How to Program Late Objects Edition, 8th edition, and read chapters 2.1 through 2.5, which you'll find is pages 37 through 52. Thank you, and I'll see you next class.